Today we're going to talk about systems of equations. By the end of this video, you should be able to solve nonlinear systems of equations by substitution and elimination. Now on to the new material. I want to solve this system of equations. I have 3x minus y equals negative 2 and 2x squared minus y equals 0. The first equation is a line, the second equation is a parabola. You can solve this by either substitution or elimination. I choose to do elimination for this problem. So my goal is to make the y terms cancel out, so I'm going to go ahead and multiply the first equation by negative 1. That gives me negative 3x plus y equals 2. And I'm going to leave the second equation alone. Now, when I add these two equations together, my y terms will cancel out. And pay attention to the details here. Negative 3x and 2x squared are not like terms, so I cannot combine them. I just end up with 2x squared minus 3x equals 2. So now I need to set it equal to 0 and factor to solve this quadratic. So when I factor this, I know that the only factors of 2 are 2 and 1. Same thing with the c term. The only factors of 2 are 2 and 1. I just need to figure out where the 2 and the 1 go and which one is positive and which one is negative. Then when I multiply these binomials back together, I need to make sure that the middle term is negative 3x. So that would make this negative 2, because that would give me negative 4, and positive 1, which would give me negative 3. Then I need to set each factor equal to 0 and solve. Now, I still need to plug these x values back in to figure out what y is. You can plug them into either equation. I'm going to use the first one because I think that it's a little bit simpler, but you can use either one and you should get the same answer. So if I plug negative 1/2 in for x in the first equation, and then I solve, I end up with y equals 1/2. So that means that negative 1/2 is one of my solutions. If I plug 2 in for x, back in that same equation again, I end up with y equals 8. So that means that 2, 8 is my other solution. So if we graphed this line and this parabola, they would end up crossing at these 2 points. Next, we have x squared plus y squared equals 13, which is a circle, and x squared minus y equals 7, which is another parabola. Again, we can use either substitution or elimination for this problem. I'm going to choose to do elimination. And I'm going to eliminate the x squared terms. So I choose to multiply the second equation. You could multiply either one. And that gives me negative x squared plus y equals negative 7. And I'm going to leave the first equation alone. So when I add these two equations together, the x squared terms cancel out, and I'm left with y squared plus y equals 6. Then I need to set this equal to 0 and factor to solve for y. So I get y squared plus y minus 6 equals 0. When I factor this, I have y plus 3 and y minus 3. Since the value of a is 1, all I need to do is look for two numbers that multiply to negative 6 and add up to 1. So I end up with y equals negative 3 and y equals 2. Now I need to plug back in to solve for x. Again, you can use either equation. I'm going to use the second one this time. So if I plug in negative 3 for x, I have x squared plus 3 equals 7, so x squared equals 4, and x equals plus or minus 2. Please do not forget, when you take the square root of both sides of the equation, you're going to end up with plus or minus in your answer. Now I'm going to do the same thing with y equals 2. And I get x squared equals 9, so x equals plus or minus 3. So this means I had plus or minus 2 that went with the negative 3, and plus or minus 3 that went with the 2. So I'm only writing this as two ordered pairs, but really this is 4 points. You have 2, negative 3, negative 2, negative 3, 3, 2, and negative 3, 2. So if we graphed this, the circle and the parabola would cross at these 4 points. Now for problem number 5, it's a little bit more challenging to figure out what type of conic sections these equations are because they're in general form, or close to general form. To solve, I need to get rid of this fraction. So to get rid of the fraction, I want to multiply everything in this equation by x so that I can cancel out the denominator and not have a fraction anymore. So you need to make sure that you distribute. So I have x squared plus x plus, and then here's where the x cancels out with the denominator. So I'm just left with y squared minus y equals 0. Now, if I'm trying to get something to eliminate from the two equations, I need to multiply one of the equations by negative 1. So I'm going to go ahead and multiply the first equation by negative 1 so that my x squared and my x terms will cancel out. So I get negative x squared minus x minus y squared plus 3y minus 2 equals 0. Now when I add these two equations together, the negative x squared and the x squared will cancel. The negative x and the positive x will cancel. The negative y squared and the positive y squared will cancel. So I just have 3y minus y, which is 2y, minus 2 equals 0. And then if we solve this equation, we get y equals 1. Now we need to go back and solve for x. You can use either equation. I'm going to choose the first equation because it's less complicated. So if I have x squared plus x plus y squared minus 3y plus 2 equals 0. When I simplify that, I have x squared plus x. These numbers will cancel out and be 0 equals 0. So to solve this quadratic, since there are only two terms, I'm just going to factor out the GCF, which is x. And so I'm left with x times x plus 1 equals 0. So then if I set each factor equal to 0 and solve, I have x equals 0 and x equals negative 1. So my two answers are 0, 1, and negative 1. 1. So these two equations, if we graphed them, would intersect at these 2 points. Lastly, we have number 6. Our first equation is an ellipse. The second one, we haven't seen equations like this yet this year. Now, if I try to eliminate a term, it's not going to work out. So I need to do substitution for this problem. I'm going to take the second equation, divide both sides by x, so I end up with y equals 4 over x. Then I need to substitute this into the first equation for y. So I have 2x squared plus 4 over x squared equals 18. So I need to square this fraction. So I get 16 over x squared. Now, I need to get rid of the fraction, so I'm going to do like I did on problem number 5, where I'm going to multiply everything by x squared so that I can cancel out that denominator. So if I distribute the x squared, I end up with 2x to the 4th plus 16 equals 18x squared. I'm going to go ahead and set this equal to 0. Now, this looks different than other problems we've seen, but it's really just a quadratic in disguise, because x to the 4th is just x squared squared. So this is really just a quadratic, but instead of x being the variable, x squared is the variable. So I can go ahead and factor this just like usual. I'm going to start by dividing everything by 2. So I have x squared squared minus 9x squared plus 8 equals 0. Now I just need two numbers that multiply to positive 8 and add up to negative 9, which would be negative 8 and negative 1. So my factors are going to be x squared minus 8 and x squared minus 1. Then I need to set each of these factors equal to 0 and solve. So if I have x squared minus 8 equals 0, I get x squared equals 8. So x is going to be square root of 8, which can be simplified to 2 square root of 2. If I have x squared minus 1 equals 0, I get x squared equals 1, and I take the square root of both sides to get plus or minus 1. So I have 4 x values here. I need to go back and plug them into one of the equations above. Now I'm going to choose to use this pink equation here, y equals 4 over x, when I'm plugging things in. So I'm going to start with the easy one first. I'm going to plug in plus or minus 1. So if I have y equals 4 divided by positive 1, and y equals 4 divided by negative 1. That just gives me 4 and negative 4. Then I need to plug in plus or minus 2 square root of 2 for x. So if I have y equals 4 divided by positive 2 square root of 2, and y equals 4 over negative 2 square root of 2. I've got quite a bit of simplifying that I need to do here. First, I can simplify the 4 over 2. Then I need to rationalize the denominator. So I need to multiply both the numerator and denominator by square root of 2. So this will give me y equals 2 square root of 2 over 2, and y equals negative 2 square root of 2 over 2. And then I can cancel out the 2's, so I end up with square root of 2 and negative square root of 2. When I write out my final answers, I need to make sure that I carefully match up the x's with the y's. So when I plugged in positive 1, I got positive 4 as my y value. When I plugged in negative 1 for x, I got negative 4 as my y value. Then when I plugged in 2 square root of 2, I got positive square root of 2. And when I plugged in negative 2 square root of 2, I got negative square root of 2 as my y value. So that means that these two equations would intersect at these 4 points if we graphed them.